Today I'll be starting a series on series. I'll be just resolving random series using different test method. So I'll be picking any problem that I think is hard from my class. So I should share with you. Maybe I found people having more challenge in solving it. So we'll be trying to work on together. So today we did something around power series. So let's try to see if we can work on it together. Maybe come up with a good solution. So this is what we have. So we are only doing problems that we think in my class were not easy for people to do. So yeah, so if you have a similar problem that you think is interesting or maybe not so easy to do, we could do it here together. You could just put in a comment section, then we work on it around power series. So let's use, I think they call it ratio test. For ratio test we want limits as n goes to infinity of an plus 1 all over an to be less than 1. Then we can conclude that whatever we're talking about converges. So we're going to take this guy and put him exactly on under our ratio test. So if I do that, I'll have limit as n goes to infinity of n plus 1 factorial all that is raised to power k, and then here I think I have x n plus 1. I'm doing the n plus 1 part, and denominator I have k, then n is the one that is n plus 1, then all that is factorial multiplied by, so if I divide by something I could just multiply by its reciprocal, right? So let me take this guy to the other side. So then I'll have kn factorial all over n factorial to the power k. Put it inside bodyguards. So this is what we have. Let's try to see if we can do something with it. Limit as n goes to infinity. Then we can't do anything here, at least for now. K, then this one become x n multiplied by some x alone, and this one will just become k n factorial, and this one will become n factorial. Okay, I hope I copied everything as it should. This I didn't divide by I didn't. I was supposed to have this one x n there, so that means I should still have it here x n. Then here denominator we have that scary looking thing. Let me just distribute it, factorial, and then it's easy to notice that that will go with that one. Also I think these brackets I need them, so let's not move so quickly. Let's do each and every step at a time so we can get to see and appreciate whatever I'm trying to show you. This thing is factorial, and then k. Now I have x alone here, k and factorial all over kn plus k factorial k. Then that guy is gone, so it's better to do observations just. Also now I think Let me cut some parts. Let me take this part. This guy look like n plus 1 factorial all to some k. I think I can write it as n plus 1 and then n factorial, and then the k will go to be distributed. There will be k here and the k here. So I meant to say I can just, instead of this guy, I can just put that guy. Let's see. Then we can take this guy, put him right there. Okay, if we do that, then this look exactly as that one. That's very nice. And then we can continue trying other stuff. Limit as n goes to infinity. What remains now? We have x, kn. Oh, I forgot that part. Let me write it. X plus 1 all power k. This guy is gone. X is still here. Kn is still here. Then here we'll have kn plus k factorial. Okay, I think that's where the interesting part comes in, or should I say that's where most people will struggle to continue. But let's do an example. Let's try for if k is equals to 3. Let's look what happens. If k is equals to 3, we're going to have this guy being 3n plus 3 factorial. Then that thing will be the same as saying 3n plus 3n plus 2. I think by now you see what factorial do. 3n plus 1 plus 3n plus nothing. I don't know why I put a plus there. It's supposed to be 3n factorial. So what basically is happening is that if we have 3, we're going to have 1, 2, 3 terms, and then have sort of factorial, right? But in this case we have kn plus k factorial. That means we're going to have I think I'll need more screen real estate here. Kn plus k factorial. This is going to equal to kn plus k. First one, kn plus k minus 1, kn plus k minus 2, kn plus k minus 3. We are going to do this thing until we have what do you call nth kth term. As much as here we did this thing until we have 3 terms. That means now we have to have 3 kth term, and then after the kth term we're going to have kn factorial. If you notice very well, this is exactly the same. We have to do this factorial thing 3 times, then we end up with 3n factorial. Here we had to do this thing k at the time until we end up with this beautiful part here, right? So if you allow me to use that on our argument here, okay, that was a very good argument to have. We can now drag this part, put it a little bit below, and continue. If you accept my argument, that means we'll have something that lim n goes to infinity. My argument was for that. Then we'll have n plus 1 k x, then k n factorial all over. This is what we have here. So because I don't want to write it again, I'll just come steal it here. Okay, let's put this part here. Okay, too big now. Now it looks really good. that's what our denominator look like. So we notice that now we can cancel this guy, right? And now we can limit as n goes to infinity. Let me just take x out of this thing because it has nothing to do with whatever mess that we are doing. I should have done that in the beginning, but it doesn't matter. And then if I take out x, I already lost that on top of n plus k. I mean n plus 1 all power k. Below we'll have this guy. He's just here. I don't know what's that. Right? And then we have this guy. Then when we hear it's worth noticing that because we're not really looking at an exact value, but I know exact means something else in math, but yeah, exact in English. So let's appreciate that this term will behave like we'll have to multiply this and that and that and that until you reach 1, 2, 3 until the kth term. So this term will behave like it is sort of k to some power k, right? And also that k is not going alone, it goes with some n. So it would be that n, this n, this n, this n, until somewhere, right? And if we do that, we'll end up having the same terms of n. They are going to be k of them. And on top we'll have some, because we're interested in behavior, we can even just write this thing as nk, because we're interested in divergent or convergent, not the exact value, right? We remove all that. So we have something that looks nice as this, but it's more than obvious that we don't need this guy. But we can now say x limits as n goes to infinity. This will also confuse you. X goes to infinity of 1 over k. So that's where our journey ends. So I think that was the trick. I think you have to appreciate how I came up with these beautiful terms after cancelling everything beautifully. And yeah, from that I think you can deduct a conclusion. But if you want to look, you can take a screenshot here. You can look at all the process and try to do it on your own after to see if you can solve. And then remember, we're doing ratio tests, so we want this kk to be less than 1. Remember, there is an x there, that means x needs to be less than k. So this is the time this thing will be converging. So I hope you try to follow up, but the biggest trick was you being able to do this. And if you can do this, everything is just your normal power series. Thank you. Please make sure that you try it on your own. Don't forget to like and subscribe if you can. Share with friends, and then also share problems that you would like us to do together. Thank you.